Hello everyone, my name is Mrs. Anthony and I teach 5th grade at Pass Road Elementary in Gulfport School District, and today we are going to be learning about the different eclipses. Our standard is standard E.5.8B.2, which says that we're going to develop and use the model of the Earth, Sun, Moon system to analyze the cyclic patterns of lunar phases, solar and lunar eclipses, and seasons. So our goal for today is just to be able to differentiate between solar and lunar eclipses. And our essential question is, what causes solar and lunar eclipses and how are they different? So let's talk a little bit about solar eclipses first. Solar eclipses occur when a portion of the Earth is covered by a shadow casted off from the moon. So if you look at our picture here, you can see that the moon is in the middle, soaking up all the good sunshine, and it's blocking the Earth. Solar eclipses are so rare because the sun, the moon, and the Earth have to be perfectly, directly aligned. Solar eclipses occur somewhere on Earth every 18 months or so. Not in the same place, but somewhere on Earth. Solar eclipses happen during the new moon phase. The new moon phase is where the moon is completely darkened. It's getting no light. And finally, or it's showing us on Earth no light. And solar eclipses happen at the same given place about every 375 years. So it is very, very rare to see a solar eclipse in the exact same place. We would almost say impossible in our lifetime. Now let's look at lunar eclipses. Lunar eclipses occur when the moon is behind the Earth and is directly in its shadow. So again, looking at our picture, we can see here that the Earth is now in the middle of the sun and the moon. The sun, the Earth, and the moon have to be very, very close or directly aligned. A lunar eclipse can only happen during the full moon phase, and they're a little less rare than the solar eclipses because we can see them about 0, so none, to 3 times a year here in the United States, where most of us probably live. So we're going to watch a video that really breaks down the difference between the two types of eclipses. Enjoy!
Hundreds of years ago, a war broke out near present-day Turkey and the Halys River. The two warring sides were the Lydians and the Medes. The war raged for 5 long years, but in its 6th year, something very strange happened. In the month of May, the fighting was brought to a sudden halt following a signal from the sky. In the middle of the day, the sun, from out of nowhere, disappeared from the sky, plunging everything into darkness. This was interpreted by both sides as divine intervention to halt the ongoing war. Herodotus, an ancient Greek historian, writes in one of his works, "Just as the battle was growing warm, the day suddenly changed into night. The Medes and Lydians, when they observed the change, ceased fighting and were alike anxious to have terms of peace agreed on." In order to heed the god's word, both sides called for a truce, which was further cemented by a special marriage. The daughter of the king of Lydia was married to the son of the king of Medes. Thus, in the end, it turned out to be a happy ending for the warring parties. However, what both sides didn't realize was that the sign from the skies that stopped their war was a perfectly natural celestial phenomenon, a total solar eclipse. NASA validated the story. Their estimation, based on solar eclipse data, is that a solar eclipse is likely to have passed over the area where the Lydians fought the Medes on May 28, 584 BC. In this case, a total solar eclipse brought peace and goodwill between two warring parties. However, our history is filled with stories where the same celestial event has instead wreaked havoc on people's lives. Today, the world has changed for the better. With an improved understanding of the skies and the unyielding laws of nature, we are now aware that such eclipses are not supernatural phenomena, but fairly regular celestial events that should not be feared, but rather examined in even greater depth. But how exactly does a solar eclipse happen? Why does the sun sometimes partially or even completely disappear from the sky for a few minutes? Well, let's start with the basics. Earth, our home planet, is locked in an elliptical path around the sun. This elliptical path is known as the orbit of our planet. Earth travels around the sun along that orbit and completes one revolution in approximately 365 days and 6 hours. As you may have noticed, this is roughly the length of 1 year. So, does that mean Earth is at exactly the same spot in its orbit every year on your birthday? Well, since it takes the same amount of time every year to complete one revolution around the sun, it's only fair to assume that on your birthday, Earth will be in exactly the same spot every year. We've actually answered that question in another video that you can watch by clicking on the I button at the top right corner of the screen. Just as Earth moves around the sun in an elliptical orbit every year, our natural satellite, the Moon, also revolves around the Earth. It takes about 27.322 days for the Moon to complete one revolution around our planet. So, Earth revolves around the sun, and the Moon revolves around Earth. Pretty neat, right? Due to all the interrelated motion happening between these three celestial bodies, several physical phenomena occur. When the new moon, during its revolution around the Earth, moves between the sun and the Earth, it blocks out the sun's rays, which casts a shadow on parts of the planet. This is called an eclipse of the sun, or a solar eclipse. In other words, a solar eclipse happens when the moon passes in a direct line between the sun and the Earth. Now, you may be thinking that the moon is infinitesimally small compared to the sun, so why is it ever able to cover part or sometimes even the entire sun? Although the moon is indeed about 400 times smaller than the sun, it also happens to be around 400 times closer to us than the sun. This is why both the moon and the sun appear to be the same size in our sky. The moon is very small compared to the sun and to the Earth, which is why the moon's shadow isn't big enough to engulf our entire planet. Therefore, the moon's shadow is always limited to a certain area. This area changes even during an eclipse, as both the celestial bodies are in constant motion with respect to one another. When the moon eclipses the sun, it casts two types of shadows on Earth. The first is the umbra, which is a small and very dark shadow. If you're in a place on Earth where umbra is cast, the entire central portion of the sun will be blocked out from your perspective. The second type of shadow is known as the penumbra. It is a larger and relatively lighter shadow than the umbra. If the penumbra passes over you, then only a small part of the sun will be blocked out from your point of view. Depending on the type of shadow the moon casts on Earth, solar eclipses are broadly classified into 4 types. The first is a total solar eclipse. This is the most spectacular of all eclipses because, during a total solar eclipse, the entire sun is completely blocked out by the moon. This can only happen when the moon is near perigee, the point of the moon's orbit when it is closest to the Earth. You can only see a total solar eclipse if you're standing within the umbral shadow. Since the Earth keeps rotating, the umbral shadow doesn't stay at one point on Earth, it keeps moving too. The imaginary line created by the umbral shadow is known as the path of totality. If you're in any of the places through which this imaginary line passes, you can see when the sun gets completely blocked out by the moon. Next up is a partial solar eclipse. This type of eclipse is observed when the moon covers only a part of the sun and casts a penumbra on Earth. Since it only covers a part of the sun, this phenomena is known as a partial solar eclipse. When the moon passes through the center of the sun, but its disk isn't big enough to cover the entire disk of the sun, then an annular solar eclipse occurs. When this happens, the sun's outer edge remains visible, making it look like a shiny, fiery ring in the sky. Unlike a total eclipse, during an annular eclipse, the moon doesn't completely block out the sun. The fourth type of eclipse is the rarest of all. When the moon's position between the sun and the Earth is so delicately balanced that Earth's curvature plays a role, we call it a hybrid solar eclipse. During this type of eclipse, some parts of the Earth witness an annular solar eclipse, while other parts see a total solar eclipse. For that reason, this type of eclipse is also known as an annular total solar eclipse. Since the moon continually revolves around the Earth, it's only natural that it sometimes comes between the sun and the Earth, while at other times it goes behind the Earth, so that the Earth comes between the moon and the sun. When the latter happens, we see a lunar eclipse. The moon completes one revolution around our planet in approximately 27 days, and rotates at the exact same rate as it revolves around the Earth. However, since the Earth rotates on its axis and also moves in its own orbit around the sun, from our perspective, the moon appears to orbit us every 29 days. Earth casts 2 types of shadows on the moon, umbra and penumbra, when it is oriented between the sun and the moon. Lunar eclipses can be divided into three types, the first being a total lunar eclipse. The most picturesque and dramatic of all, a total lunar eclipse happens when the moon, earth, and sun are perfectly aligned so that the moon falls under the umbral shadow of our planet. During a total eclipse, Earth completely blocks any sunlight from reaching the moon. Due to this, the moon loses its characteristic whitish-gray color and becomes a sunset red. This happens due to refraction from the Earth's atmosphere. The shorter blue wavelengths of sunlight are scattered outward by the atmosphere, while the longer red wavelengths are refracted inward towards the moon, giving it a reddish tinge during a total lunar.
Alright, so we're going to stop our video a little bit short because it really covered most of the things that you guys need to know about solar and lunar eclipses. But I would like to do a little bit of reading to kind of talk about the things that we heard in the video. Solar and lunar eclipses. Remember that an eclipse is when one object in space blocks an observer, that will be us, from viewing another object in space. And we know that there are two main types of eclipses from Earth, solar and lunar. So first we'll start reading about solar eclipses. During a solar eclipse, the moon passes in front of the sun, blocking a portion of the sun's light, causing a shadow to fall on portions of the earth. A solar eclipse is not seen from every place on earth, but only in those locations in which the shadows fall. It appears as if the sun has gone dark in these places. Main parts. The three main parts of the moon's shadow during an eclipse are called the umbra, penumbra, and antumbra. The umbra, the darkest part of the shadow where the moon completely covers the sun. Antumbra, not as dark because the moon is in front of the sun, but does not cover it entirely. The outline of the sun can be seen around the shadow of the moon. Penumbra, the outer area of the shadow where the moon is only covering part of the sun. Types of solar eclipses. We learned about some of these in that video. The three types of solar eclipses include total, annular, and partial. The type people see depends on the part of the shadow in which they are located. The total eclipse, the sun is completely covered by the moon. The annular, the moon covers the sun, but the sun can still be seen around the edges. And the partial, only a portion of the sun is blocked by the moon. Warning: never look directly at a solar eclipse. Despite appearing darker, the sun's harmful rays can still damage your eyes. There are special glasses made specifically to view solar eclipses safely. Fun facts: a solar eclipse will last no longer than 7.5 minutes. No more than 5 solar eclipses will occur on Earth within a year. A total solar eclipse occurs around every 1.5 years. Total solar eclipses cannot be seen from the North and South poles. And sometimes animals become confused and exhibit strange behavior during a total solar eclipse. Lunar eclipse. When the moon passes through the Earth's shadow, a lunar eclipse occurs. They have the same three parts and types as solar eclipses. A much larger area of the Earth can view lunar eclipses. They can also be viewed without wearing protective eyewear. During a lunar eclipse, the sky is not completely dark because the moon reflects some of the sunlight refracted by the Earth's atmosphere. This refracted light is reddish in color and may cause the moon to appear dark reddish brown. The 2017 solar eclipse. A total solar eclipse was visible from the contiguous United States for the first time since 1979 on August 21st, 2017. That was a few years ago. The umbra, the dark shadow of the moon, first touched the Earth's surface far over the North Pacific Ocean at 9:48 a.m. and swept rapidly to the east over the ocean for 27 minutes. At 10:15 a.m., the umbra arrived in Oregon. The moon's shadow then raced from coast to coast across the United States, a distance of almost 2,500 miles. Tennessee was the best place to view this eclipse. It took the Umbra just 94 miles to travel from Oregon to South Carolina. This calculated to nearly 27 miles per minute, or 1,600 miles per hour, about 3 times faster than a commercial jet liner. So clearly, there are some amazing things going on as lunar eclipses and solar eclipses occur. So now we're just going to make a few comparisons and do a little bit of contrasting between solar and lunar eclipses. So it says to identify the similarities and differences between solar and lunar eclipses in the chart. So we'll tell how they're different and we'll tell how they are similar. So one thing that I remember from both the video, our notes, and the passage is that both can be pretty rare. One is a little more rare, but they don't happen, or I'll say neither happen extremely often. So that's one thing that they have in common. Now, solar eclipses, let's go back to our text and see what can we find some things that are unique to solar eclipses. So, our first sentence, during a solar eclipse, the moon passes in front of the sun, blocking a portion of the sun's light. So during a solar eclipse, the moon, we're going to put that on here, the moon blocks the sun's light from the earth. So if the moon blocks the light during a solar eclipse, I know that during a lunar eclipse, it's the opposite. The earth blocks the light from the moon. So here I have ways that they are different. Another thing that I remember from the passage about solar eclipses is that you cannot look at the sun without protective eyewear. So they can be dangerous to look at. Without the proper, we'll say, eyewear. So we definitely want to remember not to look at solar eclipses with just our eyes. We want to make sure we are wearing some type of sunglasses that are specifically made. However, lunar eclipses can be looked at without special sunglasses. So those are less dangerous than the solar eclipses. Now, for something else that they have in common, let's search our passage. Okay, here I see in this paragraph it says they have the same 3 parts and types as solar eclipses. So under both, I'm going to say they both have the same 3 types. So that's one way, and 3 parts. Can't forget that. So that's another thing that they have in common. Now let's find something that is unique to solar eclipses. So we'll look back at our passage. During a solar eclipse, it appears as if the sun has gone dark. I saw that in that first paragraph. It appears as if the sun has gone dark during a solar eclipse. Let's find something that they have in common. It looks like solar eclipses are pretty short. And I can imagine that lunar eclipses don't last very long either. So we're going to say that they or we'll say neither of them last for a very long time. And finally, something that I think is so cool about lunar eclipses, it was mentioned in the video and in the passage about that reddish color that the moon appears to be during a lunar eclipse. The moon appears to be a reddish, kind of brownish color during a lunar eclipse. So, as you guys can see, they do have some similarities, but they're also very different in their own ways. So, whenever, as we said, they are pretty rare, but hopefully we'll be able to see a solar or a lunar eclipse. But don't forget, when you're looking at that solar eclipse, you better have on some protective eyewear. I hope you guys enjoyed today's lesson. I hope you learned a lot about the differences and the similarities between solar and lunar eclipses. As always, thank you all for watching. I will see you guys next time. Bye.